In this lesson, we're looking at solving some visual equations using a variety of different methods. So sometimes certain methods work better than others depending on what you're trying to solve for. Remember, solving equations is asking us to find the value of an unknown, so an unknown quantity. In the first question, we're going to be using some pictures of different bars, and we want to find the length of these bars using the information that's given. So here, from 1 and 2, you might be able to remember back to a strategy called guess and check, where you just by inspection can see that in the first question, that the bar would have to be 7 units long in order to have 2 times 7, so 2 of these bars at a length of 7 gives us 14 total. So that's what I mean by guess and check or inspection. In number 2, 5 plus 5 equals 10. So again, by inspection, you're able to see what the length of the bar is. But the reason that we don't want to use this method as much in grade 9 and we want to start using an algebraic method is because number 3 and 4 are going to be a little bit harder to sort of do that guess and check. So we are going to, instead, for number 1, try and get the length of that red bar on its own. So we are going to draw 2 red bars because there's 2 of these bars and the total is 14. If each of the bars has to be the same, then 14 divided by 2 is 7 is the length of 1 bar. In number 2, instead of just sort of guessing that 5 has to go in there, instead we're going to isolate the bar in our picture. So because we have the length of the bar plus 5 equals 10, we want to subtract 5 from both sides to get the bar by itself. So I'm going to subtract 5 and subtract 5 on the other side as well. So from the left side and from the right side. On the left side, 5 minus 5 gives us 0, and we don't even need to write that down. And on the other side, 10 minus 5 gives us 5. So now we know that the length of the bar on its own is just 5. So we're using the 0 principle there to isolate the length of the red bar. Let's see if we can use that same strategy for 3 and 4. So I have 2 bars, and their total length for both bars has to be 14.588. So the length of 1 bar then is going to be 14.588 divided by 2. You can also think of this in terms of opposite operations. We have 2 times, so to isolate the length of the bar, we divide by 2, the opposite operation. So then you can just type this into your calculator, 14.588 should be around 7 still, but it's now 7.294. And with number 3, I think you can see that it would be really inefficient to have to guess numbers close to 7. So you probably would start with 7, knowing 2 times 7 is 14, and maybe you would do 0.5. And 2 times 7.5 is 15. So you're getting closer. And you know you need to go a bit lower. So you could then sort of change your guess to 7.4. And that would give us 14.8. And then we could try 7.3, which would give us 14.6. And we'd be pretty close. But to get an exact answer, we have to use an algebraic method. So that's what we're going to have to do in grade 9 to solve equations. So number 4, same kind of question as number 2. We can subtract 5 from both sides because we have add 5 on the left-hand side. So we take away 5 from both sides. Or you can think of 5 red tiles and we need to add 5 blue tiles to make 0. We're using that 0 principle. So 1 red bar plus 0 is going to equal an answer of 4.926. Again, you could guess starting with 5. 5 plus 5 is 10. a little bit too big. And then you could try 4.9 plus 5, which would give us 9.9, a little bit closer. But you don't want to have to keep guessing to get the right answer. So it's really important that you start to think about how to algebraically solve these equations. Now I have a picture. I have 5 erasers. Each eraser, let's assume, costs the same amount. And we have some money on the other side of how much these cost. So this is $1. And we've got down here, looks to me like 45 cents, 4 dimes, and 1 nickel. So instead of having to sort of guess how much each costs, we could do that, or we could hand out quarters first to each one, and then we could think about, well, how many dimes does each one get? Well, the first 4 could get a dime, but then the last one could only get a nickel. So you could start to think about working with pennies. But instead, let's think about taking the total cost of all of the erasers. And there's 5 of them. So I'm going to take $1.45 and I'm going to divide by 5 to get the cost of 1 eraser. And then it's a little bit easier than having to split up the coins among the 5. And we don't want to have to start working with pennies if we don't have to. So we have a total of 29 cents per eraser. And you can see this would be very annoying if you had to do this by handing out pennies individually. You could start with your quarter, but then you would have to split the 45 cents into 9 cents for each one. Okay, the next question here has 2 different unknown things. So I've got 3 erasers and I've got 2 pencils, and those cost a total of, we've got $2 here, and it looks like another $1 up here, and 50 cents, so it looks like $3.50 total. If I know that each of the pencils costs $1, can you tell me how much it would cost for each eraser? I'll give you a minute to try this and then we'll take it up. Pause the video and try it. Okay, hopefully you had a chance to try this question. You could do it by handing out coins and splitting them up evenly between each eraser, because we know that each eraser is the same price. Or we could try and hopefully move towards a more algebraic method that we want to use in grade 9. So what we're going to do is we're going to start by just getting rid of the pencils. We know the pencils cost $2 total. So the pencils, there's 2 of them. They're $1 each. So they take up $2 of the bill. So $1 is $2 total. So what we're going to do is we're going to get rid of this $2. We're going to subtract 2 from each side because we certainly do not need to worry about those. That leaves us with just the price of the erasers. So we have the price of all the erasers is just $3.50 minus $2. So now we're at $1.50 remaining to split up between the 3 erasers. So now what we're going to do is we're going to just take the total amount for all the erasers, so the price per eraser then is going to be $1.50, and there's 3 of them, so we're going to divide by 3. So each eraser is 50 cents.